Hello, ladies and gentlemen. I hope you're all doing well. Root Beer here with question number 24 on our 2009 Fermat paper. We're almost at the end. We've got this question and then one more to go. So let's take a look. Question 24. Now, I do believe this is a repeat of the Cayley 25 from this year. And I do remember I solved that with greatest common divisors, but let's get into it right now. So starting with the input mn, machine A just swaps the order. Starting with mn, the output we get from the machine is another ordered pair. It still has the n at the end, but now we add 3 of the second number to the first. And machine C starts with mn and gives us m minus 2n and then an n. Natalie starts with the pair 0, 1 and inputs it into one of the machines. She takes the output and inputs into any one of the machines. She keeps doing this over and over and over again. So as an example, if we start 0, 1, she puts it into machine B, then we add on 3 times 1, and then we would add that on again. And then machine C would tell us machine A would swap the order. And then machine C would take away 2 copies of 6, so we'd get negative 11, 6. And then machine B would add on 3 times 6, which is 18. And we get 7, 6, just as they predicted. Okay? It's important when they're giving you a setup, they'll often give you an example, and you should work through the example just to make sure you understand, in this case, how the machines work, but how whatever process they're talking about works. This is especially more important on things like the Galois and Hypatia contests, and even the Euclid, where oftentimes a later, more difficult question will just create a random scenario. And usually for 1 or 2 very easy marks at the start of those contests, because they're written, you'll be asked to, just follow a set of simple instructions, not unlike this one. Okay? But it's important to make sure you understand exactly what these machines are doing, so try and follow along with their example. And that's what we've done. Which of the following pairs is impossible for her to obtain after repeating this process any number of times? Okay. So, as I already remarked, this is a Cayley question from this year. I'm pretty sure it's got to be Cayley 25. Because it wouldn't be a 24 or a 23 on the Cayley, because it never gets placed later on a Fermat. It would always be placed earlier, because a grade 10 question should, in theory, be easier. And I remember it took me a little while, and I was rambling along during that one. But if you're interested in looking at that, you can look up my Cayley video. I used the GCD, or greatest common divisor. And it turns out with these rules, the greatest common divisor of your input is always going to be the greatest common divisor of your output. I don't think I explained it too well in that video, but there's the Cliff Notes for you. Or Cole's Notes, depending on whether or not you're American or Canadian. But I think I'm going to try and approach this question in a different way, just for a little bit of variety. Okay? Because admittedly I know the answer. But I want to challenge myself. I think this way will work. I only just thought of it just as I scrolled down and saw, oh, it's the Cayley question again. So I want to see if I can do it this way. So what I'm going to do is I'm going to try and work backwards using the multiple choice nature of the contest to my advantage. Okay, well, I say advantage, but so we have to take a look and take consideration from these pairs. But here's what I'm going to do. I am going to work backwards, and I'm going to say sort of machine A. So we could reverse. Let's write properly, shall we? Reverse A. So A takes in mn, and it outputs nm. So I want to take in a pair, mn, and I just need to swap it again. A is its own reverse. Switch the order again. It's not very interesting. Now B takes in mn, and at the end I get m plus 3n n. Okay? So if I want to reverse that, whatever I take in, I need to subtract off 3 of the second number. And similarly, to reverse C, C is M minus 2N. My tablet pen does not like the subtleties in the little bumps. I would add on 2 times the second number. Okay. So I'm able to reverse each machine, and this is kind of important. So what I'm going to do is, for example, take a pair, and I'm going to try to work backwards. Now the problem is I don't know what sequence of steps they took to start, for Natalie to start at 0, 1. But what I'm going to do is sort of take a guess and always just try and pick an operation that will make my numbers smallest. So I feel like I'm going to be reversing B a whole lot, because that's the one that makes everything really small. I mean, A just swaps them around, and machine C actually adds stuff on. But we'll see where we can go with this, okay? So I'm just going to try and... so 16, 1016 and 2009. What could I do? Well, I could try and subtract off 3 times 1016. I'm going to get my calculator out. I feel like this is going to be a lot of calculation. And I would get negative 1039, 116. Now, the numbers they've got are all positive, so I might try and go back a bit. So I might reverse machine B. Or sorry, reverse machine C to add on a bit here. Call this B. So then I'll reverse C, and that'll be adding on 2 copies of 1016. So I'll get 993, 1016. And now look at that, my numbers are smaller. So I'm going to swap the order here. And now I'm going to get rid of undo machine B a bit. So 1016 minus 993 times 3. But once again, we sort of overestimate here. So we get negative 1963. That's okay. We reverse machine C, and the 993 stays where it is. So we add on 2 copies of 993. And now we've really plummeted. We're down to 23. So we'll switch the order here. Now you might notice it's taking me a bit of a little while. Well, this is just my first one that I'm going through. But this is certainly... Come on, make it a 3. There we go. But, you know, we're certainly learning a bit as we go here. So I'm going to reverse... Oh, sorry, that's reversing A. Swap them around. Now let's get rid of some 23s. This time we're going to be able to subtract a lot without any problem. Oh, not 993, 924 when I subtract off 69. And I can keep subtracting off a lot of 69s. Okay? Looks like I can do it 13 more times. So, you know, we'll skip a few steps. And it's okay as long as you understand the process to skip a few steps. As long as you're confident in your answer. Then I'll get 27, 23, and then, okay. Now I could subtract off another 69. Let's do that. Negative 42, add on a 46. By reversing C, and I'll get 4, 23, swap them. You know, it's taking a while. So, you get the sense that this probably isn't the way anyone wants you to do the question. We can subtract off 12 and get 11, 4. Subtract off another 12 and get negative 1, 4, but now we've got to add on a bit. So we'll get 7, 4. Alright, Okay, yeah, 7, 4, I guess. subtract off another 12. Get negative 5, 4. Add on another 8. And one thing that you might notice, at least a little bit here, is that B and C tend to get paired off. B, we tend to take off too much, and then we got to add on a little bit. And so you might start wondering, well, what's the net effect of B and C? And it's to just subtract off one copy of your second number. And we'll talk about that in just a moment. Our trial run's almost over. Now we do B, and we get negative 2, 3. No, that's it would be negative 5, 3. And then a C, and we'll get 1, 3. I'm just going to continue on over here rather than flip the page. So we'll flip an A, and that's 3, 1. And then subtracting off 3 copies of 1, look at that, we get 0, 1. Okay, so we know A isn't the right answer. But we might have learned some things. First of all, the BC combination just ends up taking one copy of N away. And that if I'm confident, I can just keep subtracting off things as much as I want. So this is actually going to make the process a little smoother when we do the next one. So reverse B, reverse C. Maybe we'll call that a new machine, reverse D. And this has the effect of, first we start with Mn, then in the middle we have M minus 3nn, and then we add on 2 copies of n, so we just get M minus nn. So this starts with Mn and ends with just taking off 1 copy of the n. So now we're just going to use D's and A's, taking off multiple copies of the smaller number and swapping when our first number becomes less than our second number. And this is a very rudimentary greatest common divisor algorithm. You can either make that connection as I did when I went through the Cayley, or you don't have to. You can completely omit it, but this should go a little smoother now. So 2009, what's the next one? So B, 2009, 1004. Okay, and now I can use 2 D's. I'll do it kind of slow here to get down to this stage. I'll swap it so the big number is up front. And now I can use a D again. Remember, a D is just shorthand for me doing B and then doing C, so I don't have to write so much. So doing another D, I will just subtract off 1. And 102. And, well, gosh, couldn't I just do 1,002 more of them? If I keep getting rid of 1, then I'll get 0 and 1. And so now we sort of make another realization. If I get a 1 at any point, I know I can get to 1, 0. Which is pretty nice. Okay, so B is out. How about C? So that's 2009, 1002. Alright, so I'm going to do 2 D's, just because I know 1002 doubled is 2004. And I'll get 5 1002 here. Swap them around. Okay, and if you don't need to always be writing this stuff down. I'm writing it for your benefit, not so much for mine. I can juggle a few numbers in my head. And now I'm just subtracting off copies of 5 here. And so we might ask, well, what are we going to boil down to? We're going to keep going until we get the remainder when we divide by 5, which will just be 2. All right? And then I'll swap them, 5, 2, and then I'll get rid of 2 copies of 2, and we'll be down to a 1 and a 2. Now that we've got the 1, we can swap it, get 2, 1, and subtract off those 1s, just like we swapped around and subtracted off, what was it, 102 1s last time? Yeah. So, I know at this point that C is out, because I got a 1. Okay? And then what can we do? We can do D. Sure, why not? Let's do D. Which one is D? 1008. They all start with 2009, the year of the contest. So 2009, 1008. Now I can only reverse D once here. I'll get 1001, 1008. Swap those around, 1008, 1001. Subtract, you'll get 7, 1001. And swap again to put the big number out front. Okay, and then D's here. So I can subtract off a 7, 1001 minus 7 is 994. Subtract off another one. Well, I can just keep subtracting off 7. So 994, how many? 7? Oh, 7 goes into it. So after 142 steps, I'll be down to 07. Okay. And swapping this around with an A, well, now I can't really subtract any zeros away. Now, this doesn't prove that we can't do D. It just means that I wasn't able to come up with a particular way to reverse it. Maybe there's some special trick that I need to do, 3 B's for some reason, and then an A, and then a couple C's, and I'm just not seeing it the right way. My general strategy has been get smaller numbers, because we start with 2009s and we go down to 01s. But the fact that the other 3 I got to 1 in a fairly straightforward manner suggests to me that this is not the right answer. How could I show that, not that this is not the right answer, that this is not doable and therefore the right answer? But how could I really sort of demonstrate that? Well, I can't ever say I've considered all possibilities. Now, if you watch the 25 Kaylee that I did, I talk about the GCD, I make some arguments. For this one, I guess the argument could be that no matter what I do, both numbers are multiples of 7, and 1 is not a multiple of 7. And that is enough of an argument to say, okay, 01 can't be obtained. But the way we're doing this question, the way I've elected to do it this time, I can't really say D can't be done, but I could show that E can be done, and by process of elimination, because it's a multiple choice contest, the D must be my answer. So let's move over to E, just because we're having difficulty with D. Okay, and this one is 2009. What do we start with this time? 1032. So 2009 minus 1032. 977, 1032. Swap them around. I guess I'll keep writing these out. So 1032 minus 977 is going to end up being 55. So 55, 977. So, what can we do? Swap them. 977, 55. And I can get rid of a lot of 55. So 977. How am I figuring out how many steps to do? I divide by 55. I see that's 17.76. So I just say 977 minus 1755s will do the trick. And with a whole bunch of D's, we get all the way down to 42.55. This one is taking a little while. Certainly nothing like that first one. But that's because we didn't understand the pattern. So 55, 42, and that's a difference of 13. So swap those around, 42 and 13. You'll get a remainder of 3 when you divide by 13. Swap those around. And then you'll get a 1 if you take off 3 4 times. And then, well, as soon as we get a 1, we know we can swap and keep subtracting off 1s. So we're good to go. So E's out. Therefore, D is the right answer. It's the only one we had any real difficulty with. And there we go. So a second way to do the question, more working backwards rather than saying, yeah, this looks like the greatest common divisor. It's the difference between sort of playing around with a question and having some prior knowledge. So 2 ways to do it. And there we go. And that finishes off question number 24 on the Fermat. Up next, of course, question 25. Thank you guys so much for joining me, and I'll see you in the next video.